Hey there, physics students. In our last lesson, we talked about position and time, and we made some position versus time graphs, and we learned about the slope of a graph like that. The slope of a line on a graph like that is the velocity of the object. And what we're going to do today, this is called the position versus time lab. We are going to roll a ball, and we're going to take some data about its position and time. And then we'll construct a graph, we'll make a graph, and we'll find the slope of that graph and see if we can't find the velocity of our ball. So let's get to that. Let's take a look at that. We're working on describing the relationships between position, time, velocity, and acceleration. So let's go ahead and take a look at our lab. Okay, so hopefully you have your data sheet. You might have a paper copy or it might be digital. What we're going to do is we are going to roll a ball each of these different distances, and we're going to time how long it takes for that ball to get there. And then we'll construct a graph with those numbers. And let me show you what I have set up here. I have a couple of meter sticks along the lab counter, and I have each of those distances marked. So you can see I've put a toothpick at each one of those distances. And then around over here, I have a ramp, and what I'm going to do is I'm going to roll my pool ball down the ramp. It will go along my meter sticks, and we'll time how long it takes to get from the beginning of the first one to each of the points that we want to measure. Okay, so let us set this up, and I'll try to put the camera at a good angle where you can see it pretty well. This first one should be fairly easy. Let's roll the ball and we'll time it. This is 20 centimeters, 0.2 meters. The second one, we're going to time how long it takes to get from the beginning to 40 centimeters. That's 0.4 meters right here. So our ball, we're timing from here to here. Okay, this is going to become more difficult to film as the distance gets bigger here. Now we're going to go to 60 centimeters, that's 0.6 meters. So we're going to time how long it takes the ball to go from here to here. Let's take a look. Alright, now 80 centimeters. So from 0 over here to 80 centimeters, that's 0.8 meters. Let's time this one. Okay, now we're going to roll the ball all the way to a full 1 meter over here. This is where I have a piece of tape. I've taped my two rulers together. I have my toothpick right here for 1 meter. That's 100 centimeters, 1.0 meters. We'll time from the beginning to 1 meter here. Okay, now we're going to go 120 centimeters. That's 1.2 meters. That's over here. So we'll go from the beginning here to 1.2 meters. Okay, so we'll roll the ball. So we've taken our data now, and we're going to make a graph. So I'm going to use this graphing program called Graphical Analysis. You should be able to get it for free off of the Chrome store. If you don't want to use the graphing program, that's cool. There's a graph on your lab handout. You can draw it on that graph. You can draw it on a separate sheet of paper. You can use a different graphing program. I really don't care. Whatever works for you. Okay, so I'm going to choose manual entry here. And I'm going to set up my table here on my y-axis. We're going to put the position, and we measure that in meters. On the x-axis, we're going to put the time, and we've measured that in seconds. And then my positions, which were already filled out in your data table, were 0.2 meters, 0.4 meters, 0.6 meters, 0.8 meters, 1.0, and 1.2. And then the times that we measured, you saw the stopwatch on the screen. For 0.2 meters was 0.38 seconds. 38 seconds. For 0.4 meters was 0.69 seconds. 6 meters was 0.94 seconds. 0.8 meters was 1.25 seconds. And then 1.63 seconds, and finally 2.06. All right, so we've put our numbers in there, and you can see we have a pretty nice straight line there. Let me put some graph options here real quick. We'll put a title on our graph. We'll call it the position versus time. And I would like my axes to start at 0 rather than another number. There we go. So we have a nice straight line there. I mean, it's beautifully straight. So what we're going to do is we're going to go ahead and we're going to find the slope of that line. And the slope of that line will be the velocity of my 8 ball that came off of the ramp. So I'm going to go under apply curve fit. I'm going to choose a linear fit because it should be a straight line. And here you can see it lines up pretty good. This point's a little bit below the line, this point's a little bit below, this one's a little bit above, this one's a little bit above, but they're generally really close to the line, so that's good. And we can see on our little box here that the slope, M, is 0.6016. So I think I should probably only trust that to about 2 significant figures, so we'll say that the slope is 0.60 meters per second. So my 8 ball, when it's coming off of the ramp there, is going 0.60 meters per second. Pretty neat. All right, so that was the position versus time lab. We took some data, we made a graph, we found the slope, found the velocity of the rolling ball. So pretty neat stuff there. Hopefully that helps us to be able to describe the relationships between displacement, time, velocity, acceleration, all those things. So until next time, take it easy.